We're going to take a look at some definitions that we need in order for us to do the title of what this tab is going to be. So once you make this tab, it's going to be called Curve Sketching, and you're actually going to need about 3 pages. So I think I only do 2. Actually, scratch that. You're going to need 4. I do 2, but you can do 4. So I'm going to make them as we go a little bit later on. So curve sketching. We're going to look at slope, concavity, maxima and minimas, and inflection points. What you're going to do is you're going to try and draw 4 identical graphs that kind of look like this. So go ahead and pause the video. Once you draw the first one, draw 4 identical ones that look like this. And also put in an X and Y axis. Try and get them to where they're the same. So pause the video and do what you need to do. This is a listening check. Shade in the O in the word slope, in the title slope. Alright, so first one we're going to look at is the slope. Alright, so remember the slope is what? The tangent line, right? Which is the derivative. Slope is a tangent line, which is the derivative. So if you look at that slope right there is going to be positive, right? Because it's going up. The tangent line is going up, so that's a positive slope. The slope right there is going to be negative because it's going down. The slope right there is going to be positive because it's going up. The slope right here, even though it's not so much, it's going to be negative. Right there, it's going to be positive. So that's just the definition of what slope looks like. Alright, so and don't forget, slope is a tangent line, and the tangent line is a derivative. Slope is a tangent line, and the tangent line is a derivative. Alright, let's look at maximum and minimum values. So what does that sound like? What does maximum sound like? The maximum, right? The maximum point. So this point right here where it changes, the slope changes from positive to negative, is a maximum. Where it changes from a negative to a positive is a minimum. Right? And then also the endpoints, that's a minimum endpoint and that's a maximum endpoint just because of where they relatively are. Alright, now with maximum and minimum, there's what we call a global maximum. And what global means, think of it this way, it means big picture, right? Like global is the entire world. So a global is the complete highest one. It's also known as, in some textbooks, absolute. So you'll see some textbooks is absolute, some is global. And that means of all the places it's global. So you see that maximum is bigger than the one on the left. So this one on the left is not a global maximum because it's going to only be one of those. This one's called a local. What does that mean? It's in the neighborhood. Surrounding what it is surrounded, it's the maximum according to everything else. It's also called relative. Right? This one right here, because it's the smallest or the lowest point, that's the global one. Remember, because you can only have one global, right? It's the absolute smallest one. And then this minimum right here, even though it's a minimum point, is a local or relative. Alright, so a maximum, the plural for maximum is called maxima, and the plural for minimum is called minima. Alright, so maximum looks like an N basically at the top, and then a minima is like a U but at the bottom. Alright, let's take a look at concavity, what that means. Alright, so all concavity is where the curve is bent up or down. That's just the simplest way to put it. Concavity is where the curve is bent up or down. This is a listening check. Put a box around the word concavity. Put a box around the word concavity. So if it's bent down like this, in other words, it goes from positive to negative. If it's bent down, we say it's concave down. And if it's bent up, we say it's concave up. So N is down, U is up. It's just relatively straightforward. Alright, last definition we're going to take a look at is inflection point. And an inflection point is where the function changes direction on concavity, but is neither concave up or concave down. Inflection point is where the function changes direction on concavity, but is neither concave up or concave down. This is a listening check. Underline inflection points. Underline inflection points. Think about it. See, this is concave down, but then at some point it's concave down, but at some point it changes from being concave down to concave up. At that point, that's an inflection point. Then from here it's changed from concave up to, you know, somehow going down. At that point is an inflection point. Then it changes from that to going up. At that point is an inflection point. So again, it's a function changes direction of concavity, but it's neither concave up or concave down. Those are called inflection points. Alright, so that's basically the vocab that we need before we go into curve sketching. Curve sketching is really long. However, once you get the hang of it, it's really quick, but you need to know that definition in order to do it. So let's practice and let's get curve sketching.